Okay, let's get started. So what we've known so far is that tables are stored in databases that are housed on a RDBMS system. The client interface is used to connect to the RDBMS system, the database system. The DBA is responsible for granting access to the RDBMS. And ANSI standards makes it easy for SQL writers to write SQL on several different platforms or providers. So before we get started, everything you can do in SQL, we can do in Excel for the most part. We can do it faster and with more data using SQL. We want to use SQL to do the heavy lifting in terms of data manipulation and aggregation and retrieval of data. And SQL is not here to replace Excel. So what is SQL? I've been using the abbreviation. It stands for Structured Query Language. It's a programming language. It's a coding language, programming language that allows users to access and manipulate data stored in a relational database management system. ANSI standardization makes it easy for SQL programmers to write queries using similar syntax on different systems. Okay, so I've kind of come up with a fake history of SQL to kind of tell you why we have SQL. It could have happened, but probably didn't happen this way. So back in the 80s, there was an accountant named Bill that worked very hard manually tabulating his records on a paper spreadsheet, using his calculator to add and sum and total fields that he needed for his records. He called his buddy that's a programmer and said, hey, can you create a program that kind of looks like my paper spreadsheet, but it allows me to type in the functions and the calculations and the numbers? And so that's how we got Excel. Excel, it's a spreadsheet. You can do all the functions that you would have to do manually for any type of accounting or bookkeeping purposes. Yay! So now Bill is 100 times more efficient. But hold on, his boss notices his efficiency and assigns him more work. So he goes back to his buddy, his friend that's a programmer, and say, hey, I love the spreadsheet, but I wish I didn't have to go in Excel every time I wanted to select some data or do some type of calculation. Wouldn't it be good if I just had a nice box that I could just type a command in and it would go pull the data that I actually wanted, the data I select, right? And that's how we got SQL. So now with SQL, instead of having to go into that actual workbook and Excel spreadsheet, we can actually type a command in and it'll go and it'll select the rows that we want and it'll return it in some type of spreadsheet fashion. For a SQL query, we have 5 basic clauses. We actually have more, but we'll just go over these. We have the select, and it's required, and it's going to specify what columns in the table that you want to retrieve. We have a from. This is the location of the data. We're selecting columns from what database and what table, or we're selecting columns from what workbook and what spreadsheet. That's what the from statement is for. It specifies the database and tables where the information resides. The where is not required, but you can use where for filtering your data. So I can select certain columns from a table in a database and put a filter on it. So if I was looking at a store description table, I can say, select me all the store numbers, cities, and state from the state table in some database where the state equals Arkansas or Oklahoma or Texas, whatever. Group by is not required, and you'll use that for aggregations. Right? In aggregations, whenever you want to sum, min, max, average, and we'll go over that later. Order by is not required, but it allows you to sort the data, very similar to the way you would sort data in Excel. And so what this is saying is the clauses of a SQL statement, those 5 parts that we just went over, they have to follow an order. Select always must be first. And then there's the from. I'm selecting columns from a database table. And you don't have to have in theory, you don't have to have a from clause because select 1 plus 1 is a valid SQL command. Where must be third, but it's not required. You do not have to filter data. You can select everything from a table. Group by must be fourth if there's a where present, so it comes after the select from. And you don't have to have a where, you can have select from, and then you can group by. And again, we'll go over aggregations later. And order by just happens at the end. SQL structure review. So now we're going to review the structure of a SQL statement. Oh, no, this is just a review. So list the 5 major clauses of a SQL statement. We have select from, where, group by, and order by, which is used for sorting. Okay, that is the order by, which is used for aggregations. The group by, which specifies the database and tables for the SQL statement. So what part of the which one of those 5 major clauses of a SQL statement will tells the program where to find the data? That is the from statement. And what is the select clause used for? That specifies what columns we want returned. And which clause is used to filter data? That is the where condition. Okay. Let's go over the structure and format of a SQL statement. So here's a very basic SQL statement. It says select column A and column B from some database dot table name. And that is the format and structure of just a basic select from SQL statement. You know this, so we notice the select keyword. It's going to tell us what columns that we're wanting to select. So this is the first column that we want to select. And we separate the columns by a comma. And this is the second column. And notice there's not another comma after column B, is because this column B is the last column we're selecting. If we put another comma behind that, then the parser or whatever evaluates a SQL command is going to expect another column, and it's going to give you an error. From, this is going to list what database that we're going to go to look for the table. So that's the from, and if you look at this, this will be the actual database name, the name of the database. Dot separates the database name from the table, and that's the table name. So, and we always want to end your SQL statement with a semicolon, because that tells the parser is what evaluates the SQL command to say, hey, okay, this is a complete SQL statement. We're done. Let's process this command. And so now let's evaluate a basic SQL query from a store attribute table. So say, for instance, we had a database named US database right here, and there's a table. So we're going to act like this is an actual table, right, that we're going to query. And so we get a business question. Bill gets the business question, can you provide me a list of store numbers? So what would that SQL statement look like? So this is it. Select store number, because that's the column that we want to select from US database dot store desk. So select store number, this column, from US database dot store desk. And this is what would get returned in that client interface. You would type this in the text area, and then it would put this at the bottom in the Excel type grid format. And I did not remember to put the semicolon here. It will still process, but it's still best practice to have your semicolon. And notice it put the column header of store number as whatever that we have in the select statement. That's going to be the column header for the data that's returned. And so this is going to be an exercise, and it's going to come from the store desk table. We want to pull, This is the table for the exercise, and here is the exercise. We want to pull a list of zip codes from the store attribute table. So I'll open my interface, and I'm using MySQL for this. Here's the SQL. I'm selecting zip code from the store desk table, and this is what's returned. Zip code and a list, the zip code header and a list of zip codes. And if you check down here, you're going to get the history of all the queries you've run, and you see it shows me, hey, you returned 3 rows. This is a query. I have a little green check mark that said it was a success. If you have an error when you try to run it, you'll get a red X here, but that's just for MySQL. Other databases may give you something else. Okay, so right now we just pulled a list of zip codes. We didn't filter any data. This is a very small table that I've created with just 3 zip codes in it, and this is what we returned. So now we're going to look at the where clause. Again, this is just for an example. We have our US database store desk table, and we get the question, can you provide me a list of all the store numbers with city and state for the zip code of 72756? So basically what they're asking for is they want a result set with store number, city, and state for this zip code. Here's a query. Select store number, it's the name of the column, as store NO, and we'll go over this as later. City, state from this database, this table, and this is where we use the filter, where zip code equals 72756. If you see the results, they're in the same order as what we have in the select list. Store number, city, and state. So basically what the computer or the application did was it evaluated our query, it found out what rows met this condition and returned the selected columns for those rows. So it went down and said, oh, let's find all stores that have a zip code of 72756. I know I need to return these columns, and it returned it to us in this format. Now, sometimes we'll have a column name that is not what we actually want to return in result set. And this is what the as keyword will allow us to do. It will allow us to rename the column. So we rename this store number column as store NO here, and that's what's going to be returned in our result set. Oops. Exercise, pull city and state where the state equals Arkansas from that same store description table. Okay, so here we go. We want to pull city and state from that store description table where state equals Arkansas. Notice that before, when we had the condition in the where statement, that we didn't have the tick marks or the apostrophes. So for numeric fields, you don't have to put a tick mark around the whatever you're going to be evaluating, but for text fields, then you need to have tick marks around whatever we're going to evaluate for the filter condition. So we said select city and state from this table where state equals Arkansas, and this is what is returned. So it basically went out to the database in the table, found what columns we needed, and performed that where filtering, and just returned it to us here in the cell description. So instead of you manually having to go out into a workbook or a spreadsheet, and I'm using this as an example, this is going to go out to the workbook and spreadsheet for you, filter out the data that you need, and return the columns that you want. So it eliminates that step. Rogers, Arkansas, Sanders, Arkansas. And so we're going to take a little break to talk about data types. When tables are created, each column is assigned a data type. And so some of the common data types are integer data types, and these are for whole numbers. For example, store number would probably be assigned some type of integer. And there are different derivations of the integer data type. You have small int, big int, and you may have some different types of integers, just depending on the database and how they set it up and how they want you to define each field. Decimals for any type of like a price, that would be a decimal field, or a weight, that would be a decimal field. Character fields for text values, names, city, states, descriptions, color, that would be a text field value. And you have date values, in which are just dates. So this is similar to Excel. And for Excel, you would format a column based on what you wanted that column to actually do. So if it was a column you maybe wanted to do any type of math on, you would want to format that as a integer or a decimal or one of the numeric or a currency or whatever you wanted to do in Excel. And so when we're filtering, and this is why this is important, when we're filtering data, we need to specify, we need to use apostrophes whenever there's a text or a date field. And if there's not a text or a date field, you do not have to use the apostrophes. You just use, if this was where zip code equals something, it would just say where zip code equals the number and not the text or the apostrophes. Okay, so we're going to continue on the where conditioning. Again, we have our table that exists out there in the system on the RDBMS, and we get a business question that we'll need to go query this table. Can you provide me a list of all store numbers with city and state for stores in Arkansas that are larger than 10,000 square feet? So instead of us having to manually go out there to some spreadsheet, this is going to go to the database and pull this data for us. And here's our query. Again, we're selecting store number, city, and state from this database table where size square feet is greater than 10,000 and state equals Arkansas. So we can have more than one filter for our SQL query. Again, because this is numeric, we don't have the ticks. And I'm using ticks for short instead of apostrophe. And state equals Arkansas. This is a text field. State is a text field, and we will have the text in with a semicolon. What it's going to do is going to evaluate both conditions to return data. So it'll look and it'll find all rows where size square feet is greater than 10,000. Oh, so we have these two rows. Then it's going to evaluate, all right, where state equals Arkansas. It's going to eliminate this row and it'll return this row. Voila. So we have store number, city, and state for store number 2 in Lowell, Arkansas, because this row of data satisfies both conditions. We found the row, then let's only bring back the columns that we need from that row. And this is the and. And again, the and, when the and condition is present, that means both have to be satisfied for the row to be returned. And so a note about operators. Operators can be used to filter data returned from the database in the where clause. Some of the common operators, we just looked at the equals and the greater than operators, but here are some other operators that you can use. The equal sign, which we've already went over, less than or greater than, between, so you can look at size square feet between 10,000 and 20,000 if you want it. In is used for list, and it must be separated with columns. So if you had a list of zip codes you wanted to look for, you would do in, open parenthesis, zip code 723, comma 725, whatever, and then close. And as with the data type conditions you must have, so if you had an in list and you were searching for a list of states, you would have to do tick, AR, tick, then comma, and then you can keep going like that. Not in is very similar to in, but it's just going to exclude everything in the in list. You have greater than equal to, less than and equal to, and like. This is used for wildcard searching. For example, say for instance we had where descriptions like orange. So this is going to return any row where the description column has orange in it. The wildcard says is that anything to the left of this doesn't matter. This one says anything to the right of this doesn't matter. So basically what we're saying is anything with orange in the description, let's return that row. If this wasn't present, it would have to start with orange, and then anything else to the right would not matter. Here's another one. We're stating in Arkansas. Again, we have the ticks around it, and this is just the in list. And here's another example where store number is greater than 0. So we have an exercise, pull city and state where the square foot is greater than 100,000 and the state is Arkansas. So in our table, this is the one we actually have out on the database, pull city and state from this table where square feet is greater than this, than 100,000, and state equals Arkansas. Returned one store, or yes, one city and state. We have another question. Can you provide me a list of all store numbers with city and state where the state is Florida or the store is larger than 10,000 square feet? And that's from this example data set. Okay, select store number, city, state from our database table where size square feet greater than 10,000 or state is Florida. In our results set, we get two stores. Remember with the and, both conditions had to be satisfied for the row to come back. Or it's either one. So first it's going to find all stores where the size square feet is greater than 10,000. So we have these two stores left. Or state equals Florida. So this row would come back regardless because size square feet is greater than 20,000 and the state is Florida. So this one would come back by either one of these conditions, but Lowell wouldn't have come back if we didn't have this condition. And that's the or keyword. And this exercise is very similar to what we just did in the example. We pull city and state from the store desk table where square foot equals that or state equals Oklahoma. So now we know how to pull data from a table. We know how to filter data using and or the or keyword. And we know how to use multiple conditions. So now the business question. Pull store number, city, state, size for stores larger than 5,000 square feet. Now we want to sort the data. We want to sort the stores from largest to smallest. So these are the familiar components of the SQL query. We have one more column, store number, city, state, and square feet from this database table where the size square feet is greater than 5,000. Then after the where clause, we've done our filtering. Now we're going to order by. So this is the keywords that actually allows you to sort the data. Size square feet, descending. So descending means from largest to smallest. So these are our results. It pulled back all of our stores. All our stores are larger than 5,000 square feet. So all the stores are evaluated. And now we're going to select the columns that we need because nothing got filtered out. And it ordered by size square feet, this column descending. And remember that the key word to do this is the order by. So the other keywords that we saw before, select was one word, from was one word, where is one word, order by is two words. We have to have order space by. Note about order by, it should come after the where clause. The descending and ascending keywords can be used to specify from largest to smallest or smallest to largest. And you can do this on character fields as well, date fields as well as numeric fields. Columns are sorted in order on where they are in the order by list. And let's look at this example. So if we had a query and we did order by zip code first, then store number second, it would evaluate it like you would do in the Excel sort drop-down function. Order by zip code. First, it's going to order our data set by zip code from largest to smallest. And then within each zip code is going to order by store number, smallest to largest. And you must use a comma between each column that you want to separate in the order by list. So now we have an exercise. Pull a list of store numbers and zip codes, order by zip code from largest to smallest. So we have store number and zip code. From this table, order by zip code, descending. Again, here's our question. We want a list of store numbers and zip codes, so we'll have two columns, ordered by zip code from largest to smallest. And that's the answer. So now we're going to combine, we're going to put a list of stores and store numbers and the size. So now we want store number and the size, ordered by size from largest to smallest in the state of Arkansas. So now we're going to have order by, and we're going to have another filter. This is just for repetition. Select store number, square feet from this table, where state equals Arkansas, and order by square feet descending. And as you've seen before, now whenever you're getting these business questions, it's about knowing where to add filters, where to add order bys, and this is going to help you just pull list of items, right? Maybe from an attribute table to answer some business questions. Okay, where you are now. So this is what we've learned so far. From here, you should be able to pull simple lists from attribute tables, right? We can pull store lists, we can pull item lists, we can pull date list, customer list from any of those types of attribute tables. We can filter those lists and order them accordingly. So next we'll be learning how to perform aggregations of columns. So now what we've done before is just pulled simple lists. We haven't done any summing of those lists. We haven't done any averaging of anything in those lists. This is where we're going to get into that. Next up, aggregations. Again, email me if you have any questions or comment, and don't forget to like.